Hello.
Yep. So, last time we finished setting up all the matrices, so we just had to get started on like what happens when you tap around the eye. Did you have any questions about the code before this?
No.
No, okay. So I guess we can get started here. So let me just run it again really quickly just to see where we're at. All right, so the last thing I finished or we did was we set up a matrix of all the coordinates of the pupil. So now in our function where we check for when they tap, we're gonna basically just make sure that it's not one of these coordinates. That's the first thing we want to do. So I guess what we can do is I guess the most important thing is we want to make sure it's not one of these coordinates on the outer edges. Or no, sorry. We do want to make sure it's none of these coordinates first. So I guess we can do just do a double for loop for now. Or it should be a yeah. So I forgot what this is called. Uh, for pupil matrix. And then remember, it's a three-layer array. Oh, oops. And then so inside, we'll just make sure that. Hold on, let me see. Wait, this is a bit. Those are. Oh yeah, these are the coordinates relative to the bigger array. So that means. Center. I want to make sure one of these coordinates is yeah equal to uh equal to equal to. Sorry, I need to make sure I got this. It's equal to. Oh yeah, we want to make sure. Let me see if this is. Hold on. Okay, this is a little confusing. Let me double check. No, it's not how it works. Uh, oh wait. Sorry, I need to. Oh, whoops, I had it wrong. This is... Yeah, okay. This is a really confusing syntax. Basically, we're gonna check through I buttons, which is this matrix, and then we need to get the coordinates of the pupil from the pupil matrix. So for each row or oh wait, where am I? Hold on. So we're gonna compare the button that's tapped to like a specific coordinate here, and this basically from here to here, this basically means the first coordinate will be uh the current in the current index of pupil matrix. So like here, let me print this out so we can see what it looks like. And then let's see how that looks. Oops. Oh, yeah, get a tap here. Huh, wait, is it not? Why is it not printing? Give me a second. Oh, sorry. Let's put this out here. There we go. Okay. So basically, ah, okay, this isn't really gonna help. Give me a second. I'm still figuring this out as well. Uh, never mind. I guess I just I can kind of explain it. Basically, this just talks about one specific pair of coordinates on this array because it's a 2D array. This is a 3D array, but the most inner element is just a pair of coordinates. So this basically gets us to the current coordinate, and then we specify 0 and 1 because that's how we index the most inner parts. And this is basically the x and y coordinates. But just remember from 2D arrays, we go by yx instead. So this would be, I believe, row 3 and column 11. Or column 3, row 11, sorry. And then we do the same here. This gets us our x coordinate, basically. So this is y and this is x. And we're just comparing to make sure that if their frames are the same middle x and oh wait, hold on. Yeah. And then we have to check if their y's are the same. So I'm just gonna check if this code works. Okay, so that's not the right code. uh let's see. Let's see. Hmm. Oh, wait. That's fine. Okay. I forgot this wasn't necessary. Oh my God. Okay. Earlier, I forgot that we set all the buttons, the black buttons, their tag would be 1, and then the white button, yeah, the white parts, the tag would be 0. So we didn't have to check if they tapped this because they wouldn't be able to tap it in the first place based on this code here. So I'm gonna actually comment this and just check Oh, I just want to check this out. It's my personal thing. Right. Okay. Yeah. So if we didn't tag them like this is how we would check to make sure they didn't tap the pupil, but this isn't necessary. Sorry, that was a waste of time. I'll leave this commented. Small note. Okay, so since we already know that the part they touched has to be a zero, now we just need to check if they're on like the left or right position of the pupil. So it's still pretty similar, I think. We still need a for loop or no. Let's see. If I guess we just check all the directions. So we'll first check the left side. So to check the left, we just need to make sure that the x coordinate of the part touched is less than the leftmost part coordinate of the pupil matrix. So we'll start similarly. We'll do I guess we just need one coordinate here. So if so in here, we'll check is less than, we can just get any of the left coordinates. So we'll do Google matrix and the leftmost. So we'll just do like the top left corner. So that would be 0, 0. And then we'll check the x coordinate. Oh no. I am, this gives us our x coordinate. Sorry. And this gives us our y coordinate. Dot. We want to make sure the max x of the sender is less than the top left corner's min x. And if that's the case, we'll just say we'll print for now. See how this looks first. So tap here, yeah. So it does say tap left, and anywhere else, it just says button tap, right? And basically we can just do the same for all the others. So after we determine they tap left, we can just break. And this just exits any other, it just stops checking for anything else, so it doesn't cause any conflicting. Oh no, we return. This just makes it so that it stops checking all the others. We can either do a return or we can do else if. So let's do else if instead. So next will be, let's check the right side. So we'll make sure if their minimum x is greater than the max x. So it would be the minimum x greater than the max x of the pupil. The only thing we have to change is the coordinates here. This time we can get the rightmost. So to do that, we can just start at row 0 is fine, but the column will do So this gives us the, I believe the max coordinate, yeah, of the rightmost, because we're getting the 0th row, and then we're getting the 0th row, and then the last column, which would be its length minus 1 since it starts at 0. And yeah, so let's give our x, and just copy and paste this here. And then we'll just so just keep making sure all our code is working. Okay, so that's not 100% correct. Let's see. Oh wait, this should go in the X part. Wait, hold on. Oh, if send it up for the min x. Yeah, if the minimum x is greater than the max x, sorry. So yeah, now it'll check if we tap left or right. And next we can do the top. So just keep chaining the else ifs. So this time we'll be checking their y. So if the sender's frames minimum y or their maximum y is greater than the pupil's minimum y, because we want to go up. So if this is greater than their, again, we just need to look at these to make sure they work. We can use the same point since they're all corner values. So this time, instead of checking their, hold on. Now we can keep this and just check if they're max y or min y. Double check this real quick. No, not quite. Oh wait, less than. We want to make sure their max y is less than the pupils min y. So there we have. Now we can register top, left, and then let's just add the last one. We can just it's better to make it solid condition. Okay, so this one will check if the sender's minimum what, and if it has to be greater than the coordinate. So again, we can just keep using the same coordinates because it's all relative to. Oh wait, no. This time we'll just instead of the first row, check the last row. So that'll be that gets us the length of the outer array for the matrix, and then we'll get the last index, which will be this row. And so then we can just do caps. Let's double check this real quick. Oops, there you go. Oh, this needs to copy over to here. So this gets us our bottom right coordinate. But as long as it's on the bottom, it should be fine. So we have right, bottom's not working yet. What else did I miss? If the minimum, oh my gosh, I got it mixed up still. This should be max y. There. Now we have all the directions. And so the order that you have these will be like based on the priority. So left will always be the priority checking. That means if you try to tap like the corner, it'll register as left instead of top. So that's a bit of an issue if we want to go like here. So what we can do there is we can just make each their individual checking, and then we can add variables to like actually check which direction they tapped in the end. So we'll do we'll just make them boolean. So set everything to false first. But just one for each direction. And then every time they tap on one side, we'll set it to true. So we'll do that. And then at the end, we'll just print the actual location they tap. Um, check how this looks. Oops. So if we tap in a corner now, it'll say, yeah, so the left and was it left and the top will be false, but the right and bottom will be true. So then what we can do with this is we can just check each value, and if they're true, we'll move it. Let's see. Wait, oh, this is kind of a waste. Uh, I guess it depends what you want to do. If we want it to just move a little bit. Wait, I forgot the original goal of this. Can I, Alex? Oh, is he here? Alex?
Uh,
The other one,
I want
sorry.
to, yeah,
Do you remember what we want to do with the eye when you tap it? Does it like,
I think it's supposed to like register it in like a thing and
yeah, I
then
know you want to register, but like,
yeah,
I know we want to animate this, right? Is it if
yeah,
they tap somewhere, does it just look towards that direction or does the pupil go to that location itself?
okay.
Yeah, that's what I read. If we wanted to just go to this location, it shouldn't be too bad. The other way, they're both not bad, just it's different code. So that's why I need to check with me, message him really quick, see if he's here. While we're waiting, I know I kind of rushed through this part. Do you still need like, do you want me to explain a bit about the coordinates or do you get what's happening here?
Sure, yeah.
Okay. So I'm gonna like, go with the left one. So when we check for the if we tapped on the left, first we marked sender as the button that they tapped because remember all of these are just buttons. and we'll get that button's max X value, which would be its rightmost value, right? Then next we want to compare it to the pupil. So to compare to the pupil, we want to make sure that whatever part they tapped, if it's on the left, it has to be the X value has to be less than any of the X values for the pupil. So the smallest X value we have on the pupil will be all of those on the left side, right? Because that's the closest to this part. So we're going to check if, so then that's where this indexing stuff comes in, right? So I buttons is this whole matrix, and pupil matrix is this thing we created later on. And this gives us each of these is a coordinate on I buttons for the pupil. So 311. So let's go 0, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So see how that's our top left, and this is top left of our pupil here. It's a 1 value. So that's how like the structure works. And so since we're only comparing the left side, we can just use the top left corner to represent all of these because all of these have the same minimum X value since it's all one column. That's why it can be a solid coordinate here, 0, 0. And then once we get to the third coordinate, that's just the actual inner values. So 0 would be 3 and 1 would be 11. And then from there, we're comparing the minimum X because that's the leftmost coordinate with the rightmost coordinate of the center, the max X. And that's kind of how we do it for the others. Just we mix up the values of it. We switch between min X, max X, less than, greater. That's based on like how this looks. And then that's the same for the right side, where to get the rightmost value, we index I buttons to get, excuse me. We're starting from the row 0 of the pupil matrix. And we want to get the rightmost. So that would be this one. And to get that one, it's the length of the entire matrix, which just means the length or the number of rows it has. And then we subtract 1. Wait, hold on. Oh, no. We want the row 0, and then we want the length of row 0 itself. So that would be this whole thing. And then we subtract 1 because we need to account for the 0 index. That got us 3, 8. And then, yeah, from 3, 8, we just get the y coordinate and the x coordinate. So these parts are these front, this beginning is copy paste. The only thing that's not is the 0 and 1. And similar to the y, you just map the positions based on how you see it in here, and you try to translate it there. This is a bit like a long way, but it's also probably the simplest way for now. I don't think Alex is responding, so I'm gonna just
Yeah.
move on to some code we can do for after they tap.
Okay.
So I'm gonna assume that if they tap on the button, we just want the eye to move in that direction. So if it's like that, or how about actually let's just do do you have a preference? Do you want it to move all the way to the part they tapped, or do you want it to just be like it like just slightly edges towards that direction?
Uh, maybe just have it like move there.
Like to that exact location, right?
Yeah.
Okay. So then in that case, if they tap in that direction, we want to make sure the corner touches it because we don't want it to go past, right? So to start that, we're gonna do, we need 4 if statements again. So let me just set this up first. These are Boolean values. So if left is true, If right is true, right? So now we have each one. And oh wait, no, it shouldn't be this bad. This is no, not this. Sender already has coordinates, so we're gonna wanna. Oh no, yeah, you're right. So if they tapped on the left, we want to. Let me. Oops, sorry. Where's my animate function? I didn't do any animation. Give me a second. Just gonna copy and paste this keyword here. So if they tapped on the left, let's do this first. Right. So we'll just move. Oh yeah, this isn't simple as it looks. We need to basically, if they tap left, we need to first get the coordinates of sender. And to do that, let's see. Uh, okay, let's do this. We need to log like the log the coordinates of the sender in the matrix. So let's do a double loop for the first. If I just check each one, if one of their frame mid x is equal to the sender's mid x, yeah, if they're x and oh wait, I think this is better. Oh, we can't do that. Oh wait, don't. Uh, Give me a sec. Let me check. I think there's a way to get the centers. Oh, oops. Five buttons. I. J. There we go. Huh? No. Oh, equal to center. Okay, yeah, that was easier. So center gives us the literal center of the elements. And if the button at one specific coordinate is the center is equal to the center, that means they have to be the same button. So we'll first set x equal to j and y equals to I. Because remember, matrices go by yx coordinates. So that should, let's do this with and then once we have it, we know we can just exit this. So we just break. Break just sends you out of the for loops. And what else? Okay, so now we have the coordinates. What we can do next is, let's move this outside actually. Thanks. Okay, so now if it registered a left, we'll move. Let's see how we should do this. Mm-hmm. Oh Yeah, this is gonna be a bit tricky, huh? Well, how should I do this? Because this isn't a single. Oh no, it kind of is. Give me a sec. Let me see what we can do. Um, because we would need to switch them off and slowly turn each one to the left one time. So for now, UI animate's not going to do anything because we're not changing the frame of anything. This is where a lot of math comes in. um, I guess first we'll change up the matrix array. I mean the pupil array. So counts. Okay, so we're gonna loop through everything here. Yeah, and if it's left, we'll just hmm. Let's see. We're gonna need to change the x values. The y values aren't gonna change. We just need to shift these. Okay, so let's do this. Let the difference in x will their x value minus. Let me check something else. We can get the absolute value. Yes, x. So if we tap a button here, we're gonna first check like the distance between the leftmost coordinate. Wait, no, not leftmost. The distance between. Yeah, well, we need to check the distance between these two coordinates first. I think that's the most important part. So let me move this out. So this should be the absolute value of the top left, their x value, subtracted from the x value we saved earlier of the tapped button. And then once we have that, we can loop through the whole matrix and change the value. And yeah, we need to change their x value. Minus stiff x. I don't think we need absolutely. This is 10. This is 3. Yeah, I don't think we need absolute. This should always be. Oh, wait. There will be a negative value. Hmm. All right, let me keep it there for now. If we subtract this, it'll be a negative value for sure. And yeah, okay. All right, let's see how this looks for now. Um, Wait, no, this isn't. Sorry, this is also not easy for me. First, we'll set matrix. Wait, no, that might be right. Oh no, that might be right. So we need to make sure the current one. Let's create another function to update the pupil. So I'm just trying to reset everything first before we update. So yeah, let's try this. Let's if this works, well, yeah, it'll be a lot easier for me. See. Oh, yep, there we go. Crashed. Oops. Out of error index. Okay. Uh, wait, let me run that again. New matrix I. Huh. Oh, okay. I guess this isn't part of it. Okay, so if I tap left, did anything change? Wait. Uh, you just comment this out for now. Yeah, it should, but nothing is updating. Let's see. The enter left. We update the pupil. And why isn't build I changing? Oh, it's part of build pupil. Okay, let's was it build pupil that I need to change? I think it is. Oh, Wait, I kind of forgot my stuff. Like, give me a second. Let's see. This isn't efficient. Let me try to rethink this. This isn't gonna work. We change each by X, but then, oh, let's do, buttons. Oh, okay, use coordinates. Let's try this out real quick. Set it equal to 1 first. And then we'll set see this really quickly. Nothing. Oh. What's happening? Uh, should be updating, I think, but something is wrong. Hmm. Why is it doing this? Hmm. Oh wait, because of this. Let me get rid of this really quick. There we go. Oh my god. Okay. This was resetting everything. So let me delete this actually. Okay. So let's see. It's not going any further left for some reason. Oh, it is. Okay. Ah, that's a bit weird. But okay. Basically, what we do is we go through every single element in pupil matrix, and then we shift only their x coordinate since it's only moving left. Uh, then we shift it by the distance between the portion tapped, and the leftmost coordinate of the pupil. So if the distance was 7, we shift every element by 7 to the left, which means we would subtract. And so we only have like 2 minutes, but I think once we have this, we can just, it shouldn't be that hard to do the rest, but we'll just do one for now. Yeah, I'll do distance. And this time we will shift everything to the right. So we'll add. And this time we'll do uh pupil matrix dot count. So this will get the rightmost coordinate. There we go. Oh, oh. Hold on. I don't know how that happened. I don't know why it's getting smaller here. Oh, because this logic isn't perfectly good. Um, okay, so I guess we'll finish this part by next week. Or not next week, this Thursday. I think we're meeting. So I'll explain everything further in depth then. But for now, before we go, is there any major thing you want to know right away? Or do you have a
No,
question? No, okay. So I'll send
no.
you this code just so you can look it over. But once we finish these four, I'll like thoroughly explain everything and answer whatever questions you have.
Okay,
Yeah.
okay,
All right. I don't think he's here, so I think we just go. All
okay.
right.
Bye.
All right. See ya.